Somewhere on this planet, a significant earthquake happens every 70 minutes, not during a crisis. Right now, tonight, while you are sitting there, 144 of them in the last 7 days alone. I found that number while trying to test a claim that has been spreading fast this week, that the enormous black hole which just opened on the face of the sun is a warning, and that a feature exactly like it preceded the Venezuela earthquake by 1 hour. The claim does not survive that number, but when I went into the actual scientific literature, expecting to find nothing at all, I found a correlation that does survive, and it is attached to a number that should not exist. Comment below with whether you think the sun can move the ground, or whether we are just very good at seeing patterns. Subscribe so you don't miss the moment this one develops. Now, let's get into it. Something opened on the sun this week, and it has not closed. If you could see the sun the way our satellites see it, in the extreme ultraviolet wavelengths that show the outer atmosphere instead of the blinding surface, you would not be looking at a smooth, glowing ball. You would be looking at something that resembles a living thing. Bright arcs of plasma leaping and falling back, tangles of magnetic rope, and across one whole region of the disk, a shape that is simply, absolutely black. Not dim, not shadowed. Black the way a doorway is black when you are standing outside a house at night. That black region has been growing for days. It is hook-shaped, which is a detail I keep coming back to. And over the last 24 hours, it did not fade the way these things often do. It got bigger. And it has now rotated into the one position that matters to us, which is the position where it is pointed directly at the Earth. Within hours of that happening, a theory started moving around the internet, and it moved fast, because it had a hook of its own. The claim goes like this. Roughly 4 weeks ago, when the catastrophic earthquake struck Venezuela and killed more than 2,000 people, there was a coronal hole on the sun that looked very much like this one, and it was aimed directly at Earth in the hour before the ground tore open. And so, the claim continues. The black shape currently facing us is not a curiosity. It is a countdown. There is one detail in that claim I want to flag immediately, because it is small, and it turns out to be load-bearing. The Venezuela event was on the 24th of June. Today is the 19th of July. That is 25 days, not 28. The claim rounds. And ordinarily I would not care about a 3-day discrepancy in something somebody typed quickly, except that by the end of this video, you are going to understand why the difference between 25 days, 27 days, and 28 days is the entire question, and why the human habit of rounding an interval toward a number that sounds meaningful is itself part of what we are investigating. We covered the Venezuela earthquake on this channel back in June in the video about the 800 collapsed buildings, and I am not going to retell that story here. What matters for tonight is only the scale of it. A magnitude 7.2 followed by a magnitude 7.5. More than 2,000 dead. More than 60,000 reported missing. That is the event this theory is attached to, and it is the reason the theory travels. Nobody builds a prediction model around a small tremor in an empty stretch of ocean. They build it around the ones that hurt. Now, I want to be careful with you here, because this is the kind of story where it would be very easy for me to just tell you what to think and move on. So let me start with the single, most inconvenient fact I have, and I'm going to give it to you now, in the first 2 minutes, instead of holding it until the end. Right now, as the solar wind arrives at Earth from a sun with a giant hole in it pointed straight at us, the wind is traveling at 291 kilometers per second. That is slow. That is boring. That is roughly the speed the solar wind travels on a day when absolutely nothing is happening at all. A stream from a coronal hole normally arrives somewhere between 500 and 800 kilometers per second. The magnetic field embedded in that wind is measuring 4 nanotesla, which is faint, and its north-south component, the one that decides whether Earth's magnetic shield opens or stays shut, is sitting at approximately 0. The planetary K-index, our basic measure of how disturbed Earth's magnetic field is, peaked over the last 24 hours at 1.33, on a scale where storm conditions begin at 5. The National Oceanic and Atmospheric Administration's official 3-day forecast contains a sentence I want you to actually hear because it is doing a lot of work. Quote, background solar wind conditions are expected to prevail over the 19th through the 21st of July. Background, meaning nothing. Meaning the machine is idling. There is a hole in the sun the size of several Earths. It is aimed at us, and the needle is not moving. So the obvious conclusion would be that the theory is nonsense, that I have just disproved it in under 3 minutes, and that we can all go home. Except that is not what happened when I actually went and looked. Because there is one alert still running today, on a sun that is otherwise completely silent, and almost nobody is talking about it. And there is a piece of published, peer-reviewed research from last year in one of the most respected journals in geophysics that found a real statistical correlation between solar storms and major earthquakes. Not at 1 hour, at 27 days. And 27 days, as you will see, is a number that should make the hair on the back of your neck stand up, because it is not a random interval. It is the exact amount of time it takes the sun to turn all the way around. The name is the first thing that misleads people, and I think that is worth fixing before we go any further. Because almost every argument about this topic starts with two people picturing completely different objects. A coronal hole is not a hole. Nothing has been removed. Nothing has been damaged. There is no wound in the sun, no cavity, no missing chunk of star. If you flew a spacecraft through the middle of one, and I would not recommend it, you would not pass through empty space. You would pass through solar atmosphere at roughly 1 million degrees, doing exactly what solar atmosphere does. What has changed is the shape of the magnetic field, and that is the entire story. Most of the time, the sun's magnetic field behaves like a set of arches. A line of magnetic force comes up out of the surface, curves over, and dives back down into the surface somewhere else. Both ends are anchored. And because charged particles are forced to travel along magnetic field lines and cannot cross them, all the hot plasma in that region is trapped inside those arches. It gets held. It piles up. It stays dense, and it stays hot. And in ultraviolet light, it glows brilliantly, which is why most of the sun's outer atmosphere looks bright. A coronal hole is a region where the arches have failed to close. The field lines come up out of the surface and then just keep going, out past the planets, out toward the edge of the solar system, never turning back. And any plasma that finds itself sitting on one of those open lines does the only thing it can do. It leaves. That is why the region looks black. It is not dark because something is blocking it. It is dark because it has already emptied itself out into space. You are not looking at a hole in the sun. You are looking at an open gate and at the evidence that everything that was standing near the gate has already walked through it. The material streaming out of that gate is what we care about because it moves considerably faster than the ordinary solar wind, 500 to 800 kilometers per second against a normal background of 300 to 400. And here's where it gets interesting, because that fast stream does not travel through empty space. It travels into the slower wind that left the sun ahead of it. Fast material catching slow material does not mix politely. It piles up. It compresses. It builds a wall of squeezed plasma and stretched, tangled magnetic field on its leading edge. And that wall is often more disruptive to Earth than the fast stream behind it. We call that structure a co-rotating interaction region. And the word co-rotating is the one that matters, because it tells you this whole thing is attached to a spinning object. The sun rotates. As seen from Earth, it takes about 27 1/3 days to turn once. And a coronal hole is not a temporary event like a flare that lasts 20 minutes. These features can survive for months, holding their shape through rotation after rotation, like a lighthouse beam that sweeps past you on a schedule. which means a coronal hole does not fire once. It fires again and again every 27 days until it finally decays. Hold on to that number. I promise you, it comes back. But it raises an obvious question, and it is the question that decides whether the black shape facing us right now is a threat or a false alarm. If that gate is open, and it is pointed at us, and the wind coming out of it is supposed to be moving at 600 kilometers per second, then why is the wind arriving at Earth today crawling along at 291? There are 4 conditions that have to be satisfied before a coronal hole facing Earth actually does anything to Earth. Today, at least 2 of them are not. The first is the one that surprises almost everybody, and it is the reason you should be suspicious of any argument that leans on a picture of the sun. The solar wind does not travel in a straight line from the sun to us. Think about a garden sprinkler, the rotating kind. Water leaves the sprinkler head, traveling straight outward, every drop moving directly away from the center. But the sprinkler is spinning, so each drop leaves from a slightly different angle than the one before it. And when you stand back and look at the whole pattern, you see curved arms. No individual drop ever curved. The spray as a whole spirals because the source was turning. The solar wind does exactly that. Particles stream radially outward while the sun rotates underneath them, and the result is a vast spiral structure filling the solar system, which we call the Parker spiral after the physicist who worked it out. So when you look at an image of the sun and see a dark region sitting right in the middle of the disk, apparently staring at you, you are not actually looking at the region that is magnetically connected to Earth. The stream that reaches us today left a part of the sun that was facing somewhere else entirely a few days ago. Position on the picture is not connection. This is where a lot of confident predictions quietly die. The second condition is simply time. Even a genuinely fast stream needs about 3 days to cross the 93 million miles between us. A coronal hole that turned to face us yesterday delivers, at the earliest, tomorrow. So today's silence does not actually prove that nothing is coming. It only proves that nothing has arrived. That distinction is going to matter at the end of this video. The third condition is the one I find most elegant, and it is the reason the current quiet is not just a delay. Earth is wrapped in a magnetic field, and that field is not a wall. It is more like a valve. When the magnetic field carried by the solar wind is pointed north, the same direction as Earth's field on the sunward side, the 2 fields press against each other and refuse to join, and the solar wind slides around us like water around a boat hull. But when the incoming field points south, opposite to ours, the 2 fields snap together and reconnect, and reconnection opens a door. Energy pours in. Storms happen. Auroras happen. The measurement for that is the north-south component of the interplanetary magnetic field, and today it is sitting at approximately 0, assessed as northward and not geoeffective. Over the last 24 hours, it wandered no further than 4 nanotesla in either direction. So the wind could be screaming past at 800 kilometers per second, and it would still be knocking on a locked door. The fourth condition is location on the sun itself. There are enormous coronal holes at the sun's north and south poles almost permanently, and they are almost entirely irrelevant to us because they fire their streams up and down out of the plane where the planets orbit. Only a hole that reaches down toward the solar equator or throws out a lobe in that direction sends its wind into the flat disk of space where the Earth actually lives. Put those 4 together and you get the honest picture. There is a large open gate on the sun pointed roughly at us. It may or may not be magnetically wired to our position. If it is, its stream is still in transit. And when it gets here, the door it needs to open is currently latched shut. That is not a countdown. That is a maybe with 3 qualifiers attached. And before anyone suggests the danger is coming from somewhere else on the sun instead, it is worth closing that door too, because the rest of the disk is just as unimpressive. There are 4 active regions currently cataloged. Region 492 rotated onto the eastern limb this period and is the liveliest of them, with a 35% chance of a C-class flare, 5% for an M-class, and 1% for an X-class. Region 4489 developed some small trailing spots. Region 4491 lost its penumbra entirely, which is the solar equivalent of a fire going out. Region 4490 barely registers. And the forecast discussion states plainly that no Earth-directed coronal mass ejections were observed in available coronagraph imagery. So there is no flare threat, no ejection aimed at us, and a coronal hole that has not delivered anything. On the solar side of this claim, every single box is empty. But if the coronal hole is not doing anything to Earth, then the claim we started with has a much bigger problem than I have led on so far. Because the claim is not really about the sun at all. It is about what the ground was doing at the same time. And when I went and counted what the ground has been doing, the number I found broke the argument in a way I did not expect. 144. That is how many earthquakes of magnitude 4.5 or greater occurred on this planet in the last 7 days. Not in a bad week, not during a crisis, in an ordinary, unremarkable week that nobody wrote a news story about. Divide it out. 144 earthquakes across 7 days is 20.57 earthquakes per day. 24 hours divided by 20.57 is 1.17 hours. There is a significant earthquake somewhere on Earth approximately every 70 minutes. Continuously. Right now. While you are watching this. Whatever the sun happens to be doing. I want to let that reshape the question, because it demolishes something. The claim we are testing says that a coronal hole was aimed at Earth in the hour before a major earthquake. Run that through the arithmetic, honestly. If you pick a random hour, any hour, and ask what the odds are that a magnitude 4.5 or larger earthquake occurs somewhere in the world during it, the answer is about 58%. Widen your window to 3 hours, and it climbs to roughly 92%. Give yourself a full day, and it is a certainty. Now ask the matching question about the sun. What are the odds that there is a coronal hole somewhere on the solar disk at any given moment? During this phase of the solar cycle, the answer is very close to 100%. There is essentially always one, often several. So the statement, there was a coronal hole and then there was an earthquake, is not a discovery. It is a description of a Tuesday. You have taken 2 things that are almost always happening and noticed that they were both happening. That is not a signal. That is arithmetic wearing a costume. And you can watch the 70-minute clock ticking in today's data if you know where to look. In the last day and a half alone, this planet produced a magnitude 5.7 off the coast of Chiapas, Mexico, at 17:26 Universal Time. A magnitude 5.5 near Sicaya, Peru, 10 kilometers deep, at 2:24 in the morning Universal Time, serious enough that the United States Geological Survey attached a yellow impact alert to it. A magnitude 5.5 in the Scotia Sea. A magnitude 5.3 off Kamchatka, very shallow. Plus the aftershocks, which we will come back to, because they turn out to matter enormously. Not one of those made international news. All 4 would have qualified as an earthquake happened for anybody looking to pair one with a solar feature, and the count is not static, which is its own quiet argument. In the previous data run, the 7-day tally of magnitude 4.5 and above stood at 137. Today, it stands at 144. 7 more earthquakes in roughly a day on a planet where nothing newsworthy occurred. The largest listed event also climbed, from magnitude 5.3 to magnitude 5.7, purely because Chiapas happened to rupture during the window. That is the background hum of a living planet, and it does not pause, slow down, or wait for permission from the sun. Here is the uncomfortable implication for anybody wanting to build a warning system out of this. If you announce that a coronal hole means an earthquake is coming, you will be right. You will be right every single time, forever, because on a planet producing 20 of these a day, you cannot possibly be wrong. The prediction is unfalsifiable, which feels like strength and is actually the opposite. A claim that cannot fail is a claim that cannot teach you anything. Now, I want to be fair to the argument rather than just beating it, because there is a stronger version of it available, and the people making this claim deserve to have it made properly. The Venezuela event was not a magnitude 4.5. It was a magnitude 7.2, followed by a magnitude 7.5, and earthquakes of magnitude 7 and above happen only about 15 times a year globally. So for that specific event, the seismic side of the coincidence is genuinely rare. You cannot wave it away with base rates the way you can wave away a magnitude 4.5. But look at where the argument actually breaks. It does not break on the earthquake side. It breaks on the solar side. Because the coronal hole condition is satisfied nearly all the time, a coronal hole warning is a prediction that fires permanently. It is never wrong because it is never off. And a predictor that is always switched on, and which only gets graded on the days something happens, is not a predictor at all. It is a horoscope with satellite imagery. That is the point where I expected this story to end. I had the base rate. I had the quiet sun. I had a claim that fell apart under a calculator. And then I went to look at what the actual scientific literature says about whether the sun can influence earthquakes, fully expecting to find nothing at all. That is not what I found. Before we go anywhere near the research, we need to settle a question of scale, because scale is what separates a real mechanism from a story that merely sounds like one. An earthquake is the release of stress that has been accumulating in rock for decades or centuries. Two blocks of crust are trying to slide past each other. Friction holds them, strain builds, and eventually, the rock fails. The stress released when that happens is measured in megapascals, millions of pascals, enough force to crush concrete. So if you want to argue that something external triggered that failure, you have to answer a very simple question. How hard did the external thing push? And we have an excellent way of calibrating this, because Earth is already being pushed on, constantly, by something far more powerful than the solar wind. The moon. Every day, twice a day, the gravity of the moon and the sun flexes the entire solid body of this planet. Not just the oceans. The ground under your feet rises and falls by tens of centimeters, and you have never once felt it. Those tidal forces impose stresses inside the crust on the order of kilopascals. Thousands of pascals. Which sounds like a lot until you put it next to the megapascals an earthquake releases, and realize the tide is roughly 1,000 times weaker than the event you are asking it to cause. Here is the fascinating part. That 1,000 times weaker force does do something. Researchers have looked very hard at this, most notably in work published in the journal Science in 2004 by Cochrane, Vidal, and Tanaka. And they found that tidal stresses do produce a small, measurable statistical increase in shallow thrust fault earthquakes. It is real. It survived scrutiny. It is one of the very few external triggering effects on seismicity that has genuinely been established. But notice everything that sentence contains. It took decades of accumulated data and enormous statistical care to pull that signal out. The effect is a modulation, a slight nudge in the odds, not a trigger. Nobody can use it to predict anything. The moon does not cause earthquakes. On rare occasions, the moon appears to help one along that was already about to happen. That is the ceiling. That is the most any external force has ever been shown to do to a fault, and it belongs to the largest external force acting on the crust. Any stress induced in the ground by variations in the solar wind sits far, far below the lunar tide, not slightly below, orders of magnitude below, and the mechanism has to run through a much longer chain than gravity does. Gravity reaches into the rock directly, everywhere, all at once. The solar wind has to disturb the magnetosphere, which has to drive currents in the ionosphere 100 kilometers up, which have to induce currents in the ground, which have to somehow convert into mechanical stress inside a fault zone kilometers down. Every link in that chain loses energy. By the end of it, you are talking about a whisper trying to knock over a building. It is worth being concrete about how lopsided this is, because the numbers do not feel real until you line them up. A fault that is about to rupture has been storing strain for decades, in some cases, centuries. The tectonic plates responsible are moving at a few centimeters a year, which is roughly the speed your fingernails grow, and they have been doing it relentlessly since long before anyone was watching. All of that accumulated energy is what gets released in a few violent seconds. Asking whether a fluctuation in the solar wind caused, that is a little like asking whether a passing truck caused a dam to fail. If the dam was already failing, the vibration is not the story. The 40 years of water pressure behind it is the story. That is the physical reasoning, and it is why the 1-hour version of this claim was never plausible. So, on the physics, the 1-hour version of the claim is dead. It is not close. The sun cannot reach into the crust and flip a fault on an hour's notice, because the force required is not available, and the pathway to deliver it leaks energy at every step. Which is exactly why what I found in the journals genuinely unsettled me. Because if the physics is that lopsided, the statistics should show nothing whatsoever. And in 2013, that is precisely what the statistics showed. In 2013, two researchers at the United States Geological Survey, Jeffrey Love and Jeremy Thomas, decided to settle this properly. The title of what they published tells you how it went. It appeared in Geophysical Research Letters, Volume 40, pages 1165 to 1170. And it was called, without hedging, Insignificant Solar Terrestrial Triggering of Earthquakes. What I admire about this paper is that they did not try to be clever. They tried to be thorough, in the specific way that makes a result hard to argue with afterward. They took the solar terrestrial variables you would actually want to test. Sunspot numbers, which track overall solar activity. Solar wind velocity, which is the direct measure of the streams we have been discussing. And geomagnetic activity, which measures how much Earth's own field is being disturbed. Then they took global earthquake counts and binned them by year, by month, and by day. And they sorted those earthquake counts according to how the solar variables ranked over the same periods. If the sun influences earthquakes, then the days with high solar wind velocity should contain more earthquakes than the days with low solar wind velocity. That is the whole test. It is almost embarrassingly simple, which is a virtue. They ran it across a range of earthquake magnitude thresholds, so nobody could claim the effect only shows up for big ones or only for small ones. They used standard statistical tests, chi-squared and student's t, to measure whether any difference they found could have arisen by chance. And then they did the thing that closes the loophole. They introduced time lags, because an obvious objection would be that the Earth does not respond instantly, that the effect might show up a day later or a week later. So they slid the two datasets past each other, offsetting the solar data against the earthquake data by various intervals, checking each one. Across all of it, they found no consistent, statistically significant distributional difference. Nothing. Not at zero lag, not at any lag they tested, not at any magnitude threshold. For about a decade, that was treated as the end of the conversation, and reasonably so. It came from a government scientific agency with no stake in the outcome. It tested the obvious hypothesis directly. It used ordinary transparent statistics, and it found the thing that the physics we just walked through says it should have found, which is nothing at all. When two independent lines of reasoning agree, the energy budget and the data, you are usually looking at a settled question. Everything about this should have stayed closed. In 2020, it opened again in a journal from the Nature family with a significance figure so extreme that I had to read it twice to be sure I had the number of zeros right. The paper is called On the Correlation Between Solar Activity and Large Earthquakes Worldwide. It was published in Scientific Reports, Volume 10, Article 11, 1495, in 2020, by 4 Italian researchers, Marchitelli, Harabaglia, Troas, and De Natale. Their approach differed from the earlier work in one specific way that turns out to be the whole thing. They did not test sunspot numbers or wind speed. They tested proton density. That is a subtle shift and worth pausing on. Solar wind velocity tells you how fast the material is moving. Proton density tells you how much material there actually is. A fast, thin stream and a slow, dense stream deliver very different amounts of matter to Earth's magnetosphere, and the earlier work had focused on the speed side of that. They pulled 20 years of proton density and velocity measurements from the SOHO spacecraft, which has been watching the sun continuously since the 1990s, and they set that against the ISC GEM catalog, one of the most carefully constructed global earthquake records in existence. And they reported a correlation. Specifically, they found a correlation between high proton density and the occurrence of earthquakes above magnitude 5.6, with a time shift of 1 day. The earthquakes clustered a day after the proton density spikes. The significance they attach to it is the part that stops you. They characterized the probability of the correlation arising by chance as lower than 1 in 100,000. And then they reported something that is even harder to dismiss, because it is the kind of pattern that random noise does not usually produce. The correlation got stronger as they raised the magnitude threshold. The bigger the earthquakes they restricted the analysis to, the clearer the signal became. If you were looking at a statistical artifact, you would generally expect the opposite. Cutting to rarer events normally means fewer data points and a noisier, weaker result. Getting a cleaner one as you go up in magnitude is the sort of behavior that suggests you might be looking at something real. They also proposed a mechanism, which matters, because a correlation without a mechanism is a curiosity rather than a finding. Their proposal was the inverse piezoelectric effect. Piezoelectricity is a genuine property of quartz, and quartz is abundant in continental crust and in large fault zones. Squeeze a quartz crystal, and it generates a voltage. That is how quartz watches keep time, and how some gas grills light themselves. The inverse effect runs the other way. Apply a voltage to a quartz crystal, and it physically deforms. It changes shape. It generates mechanical strain. So the proposal was this: huge current discharges from the ionosphere, driven by solar wind pressure on the magnetosphere, reach the quartz-rich rock of major fault zones and produce strain pulses in it. Not enough to cause an earthquake, but potentially enough to nudge a fault that was already at the edge of failure. I will be honest with you. When I first read that chain, I thought it was elegant. Real physical property, real material in the right place, real energy source, and a testable prediction with a specific one-day lag. Then I read the response that other scientists published alongside it, and the elegant chain developed a serious problem. It was not a problem with the physics. It was a problem with counting. A formal response to that paper was published, of the type journals call a matters arising, and its central objection was not about the sun at all. It was about how you count earthquakes. Here is the issue. When a large earthquake occurs, it is not one event. It is the beginning of a family. The main rupture is followed by aftershocks, sometimes hundreds of them, sometimes thousands, cascading over hours and days and weeks as the crust around the failed patch adjusts to the new stress arrangement. Those aftershocks are not independent earthquakes. They are consequences. They exist because the first one happened. Before you can do statistics on earthquake timing, you have to remove them. The process is called declustering, and it is not optional. It is standard practice in seismology, because an undeclustered catalog is systematically deceptive. It makes earthquakes look far more clustered in time than they truly are, which means it will manufacture correlations with virtually anything that has periodicity to it. The response argued that the 2020 analysis had not declustered the catalog. Its language was blunt. It described the omission as critically wrong from both statistics and physics points of view, and made a broader objection worth quoting because it goes to the heart of this entire genre of research. In the language of natural sciences, statistics of macroscopic phenomena can reveal nothing about macroscopic physics. That is a harder line than I would draw myself. But the declustering criticism specifically is difficult to argue with. And you do not have to take my word for it, because today's earthquake data contains a demonstration of it so clean it could be used in a textbook. Look again at what happened off the coast of Chiapas, Mexico. There was a magnitude 5.7 at 1726 universal time on the 18th. Then, at least 2 magnitude 5.3 events. Then, several magnitude 4 class events. All in the same sequence, in the same place, within roughly a day. Ask yourself how many earthquakes that is. Physically, it is 1. One patch of crust failed, and everything that followed is that same patch, and its neighbors settling into a new arrangement. But a catalog that has not been declustered does not know that. It records 6 or more separate entries, each with its own timestamp, each treated as an independent event. Now imagine running a correlation between that catalog and any solar variable. The 6 entries from Chiapas all land within about a day of each other. Whatever the sun happened to be doing during that day gets credited 6 times over. And the sun, as we established, is doing something with a very strong 27-day rhythm. Do that across 20 years, and you are not measuring whether the sun triggers earthquakes. You are measuring whether large earthquakes have aftershocks, which they do, and whether the sun has a rotation period, which it does. Multiply those 2 facts together, and a correlation can appear out of nothing at all. So we now have a genuine standoff, a null result from 2013 that was thorough and found nothing, a positive result from 2020 with an extraordinary significance figure and a plausible mechanism, carrying a methodological objection serious enough to potentially explain the entire finding. That is where the field sat. Unresolved, with both sides holding something real. And then, last year, a new paper arrived that did the analysis properly on the largest earthquakes we have records for, using a method designed specifically to hunt for time lags. It found a correlation. It just was not at 1 day. The paper is titled On Solar-Terrestrial Interactions: Correlation between Intense Geomagnetic Storms and Global Strong Earthquakes, published by Chen and colleagues in Geophysical Research Letters, the same journal that carried the 2013 null result. Their dataset is the most aggressive attempt anyone has made at this. They went back nearly a century, pulling the record of intense geomagnetic storms, and set it against global earthquakes of magnitude 7.5 and above. That threshold is doing important work. Magnitude 7.5 is rare enough that you are looking at a small number of events, which is statistically inconvenient, but it also means you have almost entirely escaped the aftershock problem. Aftershocks are smaller than main shocks. When your catalog only contains the very largest events, the contamination that wrecked the earlier analysis mostly disappears. They also built a new technique for the job, which they call shift neighborhood matching correlation. The purpose of it is to scan across many different time lags and ask, at each one, whether storms and earthquakes line up more often than chance would allow. you are not testing a single hypothesis about a single delay. You are sweeping the whole range and looking for where, if anywhere, a peak appears. A peak appeared. It sat at a lag of 27 to 28 days. Earthquakes of magnitude 7.5 and above became measurably more likely roughly 4 weeks after intense geomagnetic storms. They state that conventional statistical methods confirmed the significance of the correlation. Before I tell you why that number should raise every alarm you have, I want to give these researchers the credit they have earned, because their own caveats are as important as their result, and they place them right in the paper. They state explicitly that the correlations do not establish causation. They state that the earthquake probability gained from geomagnetic storms alone is, in their words, far from satisfying prediction. And they say the findings' value would only be as one input among many inside an integrated multi-parameter model, not as a warning system on its own. That is what honest science looks like when it finds something it cannot fully explain. Nobody in this paper is telling you to evacuate. They went further, and this part is genuinely surprising. They evaluated the candidate mechanisms, and they concluded that an electrokinetic mechanism could potentially explain the effect. While the inverse piezoelectric effect, the mechanism proposed by the 2020 paper, cannot be considered plausible. So the most recent serious work in this field simultaneously found a correlation and dismantled the physical explanation that the previous positive result had been built on. The two papers that both claim a solar seismic connection do not agree with each other about how it could possibly work. An electrokinetic mechanism, for what it is worth, is a more patient idea. It involves electrical currents driving the movement of fluids through porous rock. And fluid movement through a fault zone is slow. It takes time, which is the first thing in this entire investigation that would actually explain a delay of weeks rather than an hour. That is the reading that makes the number meaningful. There is another reading, and it makes the number meaningless. The sun turns once every 27 and a third days as seen from Earth. The correlation peaks at 27 to 28 days. I need you to sit with how uncomfortable that is, because it is not a small coincidence. It is the single most important fact in this video, and it can be read in two completely opposite ways, both of which are entirely reasonable, and nobody has yet done the work required to tell them apart. The first reading is that the delay is physical and real. Something in the coupling between a geomagnetic disturbance and the solid Earth operates on a timescale of about 4 weeks. Slow processes do exist in the crust. Poor fluid pressure diffusing through a fault zone is one of the slowest and best documented, and it is precisely the sort of process an electrokinetic mechanism would drive. Under this reading, a storm arrives, currents flow, fluids begin to migrate through rock at the pace that fluids migrate through rock, and about a month later, a fault that was already close to failure gets its final push. The second reading is that the correlation is the sun's rotation leaking into our statistics, and nothing more. Follow this carefully, because it is subtle. If you have a solar variable that repeats every 27 days, because the same coronal hole keeps sweeping past, and you scan across time lags looking for where earthquakes cluster, you will find a peak at 27 days. But that peak might not represent Earth responding 4 weeks late. It might just be the next storm. The apparent lag would be nothing but the interval between one appearance of the same feature and the next. Under this reading, the 27-day signal is not the sound of the ground answering the sun. It is the sound of the sun repeating itself, echoing back through our analysis and being mistaken for a reply. Both readings fit the data we currently have. Distinguishing between them requires careful declustering, controlling for the periodicity of the solar variable itself, and testing against synthetic catalogs built to have no real connection at all. Until somebody does that, the 27-day correlation is a finding that cannot be interpreted. It is a genuine result pointing at two incompatible conclusions. And here is where I want to close the door on one thing firmly, because this is exactly the gap where the tidier explanations rush in. The idea that any of this is being hidden from you collapses the moment you check. The Global Earthquake Catalog is public. The SOHO solar wind data is public. The Geological Survey's earthquake feed updates in near real time and costs nothing. The 2013 null result was published by a government agency and says the correlation is not there. The 2020 positive result is in a Nature Family Journal and says it is. The rebuttal is published alongside it. Last year's paper is in the leading journal in the field and hedges its own conclusions in print, in public, where anyone can read them. That is not a cover-up. That is an argument happening in the open that has not been won yet. And the claim that some facility is engineering all of this runs into the wall we have hit on this channel before. A coronal hole is a magnetic structure spanning a region many times the size of this planet. A magnitude 7.5 earthquake releases its energy from a rupture surface tens of kilometers underground. Both cite many orders of magnitude beyond anything human infrastructure has ever produced or ever could. Which brings us back to the sun that is sitting there, quiet, with a hole in it, doing nothing that anybody is watching. Except that is not quite true either. Because there is one alert running today. It has been running for 3 days. And it is the only thing on this entire list that is genuinely, measurably dangerous right now. On the 17th of July, at 1750 Universal Time, a detector on the GOES 18 satellite crossed a threshold and triggered an alert. It has not stopped since. The measurement is the flux of electrons with energies above 2 mega electron volts, and the threshold is 1,000 particle flux units. When the first alert went out, the comment field recorded the previous day's maximum at 1,382. The following day, a continuation was issued, serial number 3718, logging a maximum of 1,085. Today, a third continuation, serial number 3719, logging 1,170. 3 consecutive days of alert extensions, and the forecast expects those high levels to continue. Now compare that to everything else on the board today. The geomagnetic scale reads G0, nothing. The radiation storm scale reads S0, nothing. The radio blackout scale reads R0, nothing. Proton flux is sitting at 0.211 units against a storm threshold of 10, which is not close to anything. X-ray output is in the B range, the quiet range. Aurora power is 15 gigawatts in the north and 16 in the south, below the 20 gigawatt benchmark that already counts as calm. Every needle on the dashboard is pinned at 0 except one, and that one has been in alert status for 3 days. I want to be precise about what this is, because it would be very easy to oversell it, and I am not going to. This is not a radiation storm. This does not affect anyone on the ground. It will not knock out your power, your phone, or your car. If you spent today entirely unaware of it, you lost nothing. What it does is charge satellites. High-energy electrons at these levels do not simply strike a spacecraft's outer skin and stop. They have enough energy to penetrate the hull and bury themselves inside the insulating materials in the interior. And they accumulate there, deposit after deposit, over hours and days, building up an electrical charge deep inside components that were never designed to hold one. Eventually, that buried charge finds a path and discharges internally, inside the electronics, in a place no external shielding can protect. Engineers call it deep dielectric charging, and it has ended satellite missions. Here's the part that ties it back to the black shape we started with, and it is the quiet inversion at the center of this whole story. Where did those electrons come from? Not from a flare. There have not been any worth the name. Not from a coronal mass ejection. None have been aimed at us. The database logs exactly one high-speed stream in the recent record, arriving on the 14th of July at 22:24 Universal Time, observed by half a dozen instruments across multiple spacecraft, and that stream is formally linked in the database to a radiation belt enhancement event on the 16th. The electron alert crossed threshold on the 17th. A stream from a coronal hole arrived. 2 days later, the radiation belts responded. 1 day after that, the alert began. And 3 days after that, it is still running. That is the entire footprint of a coronal hole stream on Earth. A brief bump in the K-index on the 15th that nobody noticed. No storm. No aurora worth driving for. And a multi-day accumulation of high-energy particles in exactly the region of space where several thousand satellites happen to live. So the coronal hole does have a genuine, documented, ongoing effect on this planet's technological infrastructure. It is just not the one anybody is looking for, and it does not involve the ground at all. There is one more number in today's data that I have been holding back, because it reframes everything else once you have it. The sunspot number for June was 94.4. A year ago, it was more than 20 points higher, and the monthly series peaked at 133.7 back in August of 2025. The sun is winding down. We are on the far side of solar maximum, heading into the declining phase of the cycle. Most people hear that and assume the danger is passing. It is not passing. It is changing character. As sunspot numbers fall, coronal holes do the opposite. They grow larger, they survive longer, and critically, they migrate down from the poles toward the solar equator, into the plane where the planets orbit, and where their streams can actually reach us. The declining phase is the coronal hole phase. That is not an anomaly of this cycle. It is the signature of it, which means the black shape facing us right now is not an aberration. It is the first clear sign of what the next several years are going to look like. Fewer dramatic explosions, more recurrence. A sun that stops shouting and starts tapping every 27 days on a schedule for years. And that is why the 27-day number will not leave me alone. Look at what we actually established. The 1 hour claim is dead, killed by a planet that produces a significant earthquake every 70 minutes and a sun that almost always has a hole in it somewhere. The mechanism for a fast trigger is dead too, buried under a tidal force 1,000 times stronger that manages only a whisper of an effect. Those things are settled, and I am comfortable saying so. But underneath the claim, at a timescale nobody on the internet is talking about, there is a real correlation in a real journal that nobody can currently interpret, attached to a number identical to the rotation period of the object producing the signal. Either the ground answers the sun 4 weeks late, or we have spent a century listening to the sun turn around and mistaking the echo for a reply. I find the second possibility more unsettling than the first, and I want to explain why, because it is not the answer you would expect. If the sun triggers earthquakes, that is frightening, but it is also useful. It would mean a warning exists. It would mean the sky tells you something about the ground. If the correlation is an artifact, then what we are really looking at is a mirror. It means the pattern was never in the data. It means that a species which evolved to survive by spotting patterns has been handed a planet that generates a significant earthquake every 70 minutes and a star that repeats itself every 27 days, and has been finding meaning in the overlap ever since, because that is what we are built to do. The claim that started this video is not a failure of intelligence. It is intelligence working exactly as designed, on a problem designed to defeat it. We cannot predict earthquakes. Not one. Not anywhere. Not with any method. And the absence of that ability is a genuine hole in human knowledge that no amount of pattern matching has ever filled. That is the real reason a black shape on the sun feels like a warning. Not because the evidence points there. Because we need the sky to know something the ground will not tell us. So here's the thing I will actually be watching, and I would encourage you to watch it too, because it is checkable and it has a date attached. The hole is facing us now. Transit takes 2 to 4 days. If the correlation reported last year reflects something physical rather than a statistical ghost, the window it implies from the current configuration opens somewhere around the 15th to the 17th of August. Magnitude 7.5 earthquakes are rare enough that the honest expectation is that nothing happens at all. And I want that on the record now, in advance, rather than assembled afterward from whatever the world provides. Because the difference between a prediction and a story is entirely a matter of which one you say first.